Hello everyone, so welcome to my YouTube channel. So last class we have studied about thermodynamics, so this is the second video and we are going to continue more about the thermodynamics. So here we are learning about the thermodynamics of the based upon like NCERT level. Okay, so it is totally the NCERT level, and the very important thing is that I will tell you that I will be uploading the video daily from now onwards. Okay, for this chemistry NCERT based. So first I will complete the important chapter of the first 11th standard, then I will move for the 12th standard. So 12th standard I am going to complete the whole chapters, the whole syllabus, you can say. I will upload the whole syllabus. And the very important thing is for this, guys, don't go and search in the go to my channel, then don't go to the videos and search. No, because here you will get the randoms, because I am uploading for CA foundation, CS foundation, then JEE NEET and CET past year question for the chemistry. Then I will be uploading this, okay, like NCERT based for the 11th and then the 12th. So if you'll go and search in the video, it will be like you will get confused. Okay, so what you have to do is go to my channel and directly go to the playlist. Okay, go to my channel, directly go to the playlist. In the playlist you will see a thermodynamics playlist. So open that thermodynamics playlist and you will get the thermodynamics. Okay, and then in playlist you will get the one more playlist, that is the JEE NEET CET PYQ for chemistry. Okay, so you have to go to the playlist, then in the playlist you will get to know. Okay, otherwise you will search in the video, तो भैया मोए will happen. मजा आ जाएगा जी, मजा. चलो चलो भैया चलो आ जाओ. Okay, so what we are going to do here is bakaiti. No, okay, so कौन सा color which color do you choose? चलो red color. So now guys, we are going to study today. See, today is a very important topic in which we are going to learn about the sign convention of heat and work, and then we will learn about the first law of thermodynamics. Okay, so heat is denoted by Q and work is denoted by W. So heat is denoted by Q and work is denoted by W. So heat and work both is considered as a energy. So heat energy, work energy. Okay, because why energy? Because for doing anything like work, for doing any work, we require energy. If work is done by ourselves or work is done what upon us, so for both the thing energy is required. If you are doing a work upon anything, so you are applying the energy, or if some person is doing the work upon you, means yes, that person is applying the energy. So everywhere energy means energy is energy concept will be there. Okay, energy is being utilized. So heat and work both is considered as a energy, heat energy or work energy. Okay, now let's start. So whenever we talk about the heat, so here the basically we'll consider main thing as a system. Last class I have said you guys, in the thermodynamics we'll focus only on the system, we don't care about the surroundings. So when we talk about the system, so two things will happen in condition of heat. Either heat will transfer from the system, and where it will go, yes, either the heat will transfer from the system to the surrounding, or the heat will either heat will transfer from surrounding to system. Okay, so what we will say that two things. First thing is system will absorb the heat. Second thing is system will release the heat. So totally thing we will talk regarding to the system. We will not say, see, in very rare case we will say that system release the heat, heat is released from system to surrounding, and what, heat is released from surrounding to system. So this we will say very rare case. So what we will say the two things. First thing is heat absorbed by the system and heat released by the system. So that's why you will understand the concept when we have to apply the positive charge, when we have to apply the negative charge. Okay, so what we will see, guys, this is the system, this is the system. Okay, this is the system. So what will happen in the system? Okay, this is the, let's suppose this is the system. Okay, the first condition, guys, what will happen? Heat is absorbed by the system. What is happening? Heat is absorbed by the system, So this is the system. Okay, this is the system, and this is the other part is surrounding. As we know, we don't care about the surrounding, we'll focus on the system. So what we will see, first thing is heat is absorbed by the system. Heat is absorbed by the system. So what will happen when heat absorbed by the system? So what will happen, the temperature will increase. Obviously the temperature will increase, because when heat is absorbed by the system is absorbing the heat. So what is happening inside the system, the temperature will increase. The temperature will increase. And what is happening, heat is absorbed by the system. Heat is absorbed by the system means heat is coming in the system. Heat is coming in the system. So inside means it is endothermic process. It is endothermic process. Okay, first condition is what? First condition is heat is absorbed by the system. So if heat is absorbed by the system means heat is coming inside the system. Heat is coming inside the system. So inside the system means endothermic process. And when the heat is inside the system, so the system temperature will increase. System temperature will increase. So what will happen to the heat? Heat will become positive. Okay, in this condition the sign we will take as a positive. Why positive? Because heat is on the system. Heat is on the system means what? Heat is going on the system, because system absorb the heat. So that's why temperature will increase. So heat is acting on the system. So it is positive sign. Next, second condition is what? Heat is released by the system. Heat is released by the system. So everything we are going to study from the system. So main thing, as in the first class only I said you, we will only focus on the system. Our main motto is system only. Okay, system only, system. Okay, cholo jaldi. So what will happen? Hey, don't write anything, guys. I will give you the proper notes. Don't write anything. Okay, so next thing is what? Heat is released from the system. Guys, if heat is releasing from the system, what is happening? Yes, heat is releasing from the system. So if heat is releasing from the system, what will happen? The temperature of the system will decrease. Why? Because heat is released from the system. And where it is going? Gottilla. Means we don't know, we don't care about that. Just we have to see that whether system is absorbing the heat or whether system is releasing the heat. So in this condition, second condition, what? Second condition is heat is released by the system. If heat is released by the system, what is happening? Heat is released by the system means temperature of the system will decrease. Temperature of the system will decrease. Now the process is heat is released by the system means heat is going out. Going out. Out means what? Exit. So it is exothermic process. It is exothermic process. And what is the condition? What is we are seeing here? Heat is going out from the system. Heat is going out from the system, or system is releasing the heat. So if heat is going out, then we will take the negative. The first condition is about the heat. Okay, very important thing. First is what? We are talking about heat. In that, first thing is when system will absorb the heat. When system is absorbing the heat means system is absorbing the heat. So just we have to see that heat is coming in the system or heat is going out from the system. That's it. Same we have to see for the work also. Work is done on the system or work is done by the system. Okay, that's the two things we have to see. We don't care about anything with the surrounding and all. Okay, the first thing is heat. Chalo jaldi तो देखिएगा भैया जल्दी. First thing is what? Heat. So heat में what we will see first thing is if system absorb the heat means heat is going on the system. This black wala heat is going on the system. If on the system means heat is going on the system means some system temperature will increase. Okay, and the process, what the process will happen? Heat is on the system means system is absorbing the heat. Means heat is going inside. Inside means endothermic process. Okay, so if anything is happening on the system, it is positive. So here also you can see heat is on the system. Heat is acting on the system. Why? Because system is absorbing the heat. So heat is acting on the system. On the system, anything is on the system, that is positive. Second is, you can see heat is released by the system. If heat is releasing by the system means temperature will decrease. Why? Because heat is going out of the system, the temperature will decrease. If heat is releasing, the temperature means what is happening? The temperature is going out means exit. So exothermic process. Okay, and here you can see this process is not on the system, this process is by the system. Why? Because heat is releasing by the system. Heat is releasing by the system. By the system is negative, on the system is positive. Okay, so that is for the heat. Now next thing is, see, we will just read it. Understand guys one thing, these are the notes what you have to write. So I will not write the notes, these are the notes what you have to write. These are the notes what you have to write. So I will stop while explaining, so you can pause, you can take the screenshot, or you can pause and you can write the notes. So these are the notes what you have to write. Okay, I will tell you, and then these are the diagrams what you have to draw. So understand one thing, what I will say and what I will tell you to guys, first write on this, then draw the diagram, first write on this, then draw the diagram. You have to do like that only. Okay, don't start copying, then you know that when to draw the diagram, when not to draw the diagram, then gibberish things will happen and moe will happen. Okay, so chalo bhai, jaldi focus here chalo. Whoever the person is in your mind, keep that person aside and focus here, focus mari. First what you will write, first you will write the topic heat and work. After that you will write down this: heat is the energy transferred to or from a system. Heat is the energy transferred, obviously I said heat and work is the energy only. So heat is the energy transferred to the system or from the system due to temperature difference. Due to temperature difference it will happen. Temperature difference means if system temperature is less, surrounding temperature is more, so system will transfer from surrounding to system, means system will absorb the temperature. If system temperature is more, surrounding temperature is less, so system will release the heat to the surrounding. Okay, so exothermic process. So that is called temperature difference. If both the temperature will become equal, like heat, like system temperature is also same, surrounding temperature will also same, so that will come under equilibrium condition. So now the transfer will get stopped. Okay, transfer will only happen in the case of temperature difference. Very important point. Okay, so if see what this is the point, important point, the notes point. Okay, but if you listen my explanation and in that you think that okay, 2.3 points are still important for yourself, you can write it down. So please first write down till here, then after that pause the video and then make the important point, give the arrow and write down the important point what you think from my explanation. Okay, so it's up to you. If you understand, chalega bhai, nahi to you have to write down. Okay, so heat is the energy transfer to the system or from the system due to temperature difference. Very important thing as temperature difference. They will ask in the examination also. So basic is very important. If basic is good, you can clear for the JEE, NEET, CET, any examination, Comet K, any exam, CUET, any exam you can go with. So very important thing is the concept clear. NCERT का concept clear होना चाहिए भाई. So temperature difference means okay, whose temperature will be less, the heat will flow to that side. Understand, where the temperature will be less, the heat will transfer to that side. If suppose system temperature is more, surrounding temperature is less, the heat will transfer from system to surrounding, higher concentration to lower concentration. Okay, and if suppose the surrounding temperature is more, system temperature is less, then heat will transfer from surrounding to system. So heat will transfer in a condition where there is a temperature difference. If both the system temperature and surrounding temperature will become equal, they will come under the equilibrium condition. So no heat transfer. Okay, heat transfer will be 0. Okay, now this point, when a system absorbs heat, its temperature increases. I have explained. So it is endothermic. And when it releases heat, its temperature decreases, exothermic. Write down till here, write down till here. Okay, second point, from here write down till here, then after that draw this diagram, and in the diagram write down the same thing how I have written. Okay, if you wanna change the color, you can change the color also. Okay, this is done for the heat. Now we will see about the, now next is what, work. Now we will see about the work. Okay, so now we'll see about the work. So this is, we have to learn about the work. So work, what we will learn, very important thing, we will learn the work by the piston method. Okay, we will learn by the piston method. So this is what, this is a piston, this is what, this is a piston. Okay, this is a piston, the black color, this is a piston, and inside that we will fill the gas. Inside that we will fill the gas. Inside this we will fill the gas. Okay, now what will happen, we will do the work done. Now see, work done on the system, this is what, on the system. Work done is on the system, this is what we are doing the work. Okay, work is done on the system. Guys, what I said you before, if anything is on the system, anything is on the system, positive. Anything is by the system, negative. So work done on the system, work done is what, work done is happening on the system, so it is positive. Now see here what is happening, this is a piston and I am doing the work done on the system, means work done I am doing on the piston. So what will happen, the piston will move down, the piston will move down. So that process is what, that process is called compression. That is what, that is compression, that is compression. Now next thing is what, system. Now next thing is what, work done is by the system, work done is by the system, work done is by the system. Okay, work done is what, work done is by the system. Cholo bhaiya joldi joldi the somjhori devo. Cholo 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 cholo, here focus here, focus here. Work done is by the system, work done is by the system, work done by the system. By the system means negative. As I have said you, on the system positive, by the system negative. Whatever on the system, anything, if you see the arrow like this, work arrow is going down on the system, means it is positive. Here you can see heat is on the system, heat is going on the system, positive. Here heat is going, like heat is, like, you know, by the system, so releasing by the system, going away, so that is negative. Here also work is done by the system, going away, negative. So in this condition what will happen, in this condition work is done by the system, from down the work is happening, the down work is happening to the system. So in this condition what will happen, the piston will move up. In this condition what will happen, the piston will move up. If piston will move up, it is what, compression का क्या बोलते हैं, contraction, expanding होगा, हाँ expanding guys, expanding ही बोलते हैं ना, compression हाँ expansion बोलेंगे, yes expanding guys, expansion बोलेंगे, expansion, sorry guys, sorry I forget that word guys, sorry oh okay. Understand, this is the work. If work is done on the system, anything is happening on the system, then it is positive. If anything happening like away from the system, or by the system, or from the system, negative. Okay, so that is compression, that is expansion. So here what will happen, in expansion the volume will increase, compression volume will decrease, because it is compressing. So what will happen, this is before, compression means volume will decrease. Okay, volume decrease, and here what is expansion means, it expanding means what, volume is increasing. So here we will write volume increase. Okay, so how I am saying, you have to write down like that only. Okay, now come to here, now we will write from here, work is the energy, obviously it is also energy. So work is the energy transferred when a system exert force. When the system exert force, system is exerting the force, or force is exerted on the system, which results in volume changes in both the cases. Okay, the two condition, either when the system, when the system exert the force, from downside the system is exerting the force, the piston will go above, volume changes. Or force is exerted on the system, upon the system means upon the piston I will apply the force, the force is exerted on the system, the volume changes will happen. Okay, so write down till here, from here to here you write down. Okay, and then draw this whole diagram. Okay, and write down the same thing what I have written. So till here I hope your part of the notes what to write it's got cleared. Now next we'll go for the internal energy. See, internal energy is U. So if I will use delta, delta means change. Delta U means change in internal energy. Delta U means change in internal energy. So whatever the energy, it will change. Why? Because it will change according to the initial and final. And I've given you the homework also to write down the path function, right, and the state function. So there also you will get to know about the internal energy. Internal energy is what? Means change in internal energy. Internal energy is a state function. Just we have to see the initial internal energy and the final. We will not care about the, what you can say, the work process, like how it is changing. Okay. Okay. Fine. So internal energy is what? Internal energy is denoted by U. So internal energy is kinetic energy plus potential energy. Internal energy is what? Kinetic energy plus potential energy. So see, we will write from here till here in the notes. We will write from here till here. So first understand, internal energy represent the total energy contained within a system due to motion of the particles. See, within a system. So what will happen? Internal energy means represent the total energy contained within a system. Suppose this is a system. So total energy contained within a system due to motion of particles. Because gas particles will be inside the system. You can see here. Gas particles will be inside the system, right? Gas particles will be inside the system. So what will happen? The gas particles will move. Correct? Obviously, the gas particles will move. The movement means what? We'll get the kinetic energy, right? Movement of particles means what? Kinetic energy. If there is a movement, kinetic energy. So that's why they said internal energy represent the total energy contained within a system, inside the system due to motion of particles. That is kinetic energy. Motion of the particle, the gaseous particles. Or if you'll keep the water particles, right? The motion will happen here. Because water, gas, what will happen? Liquid, gas, it can flow. Their particles can flow. The flow means movement. Movement means kinetic energy. And interaction of its particle, that's potential energy. Okay, understand one thing guys, which is very important. Motion of particles. See, inside this system we will take either liquid or gas. We'll take either liquid or gas. So we know the force of interaction between the liquid and gas is weak. So that's why the particles of liquid will move and the particles of gas will also move. So particles of liquid move means what we will say? Movement of particles. Movement of particles. So whenever the word movement will come, it is a kinetic energy, because kinetic energy formula is half into mass into velocity square. So what is the velocity? When there is a movement, right? When we are moving, then only velocity will generate. So that's why if there is a movement of particles, movement will be there means kinetic energy. And if the interaction of the particles means the force of interaction. Interaction means the force of interaction between the particles. If there is a force of interaction between the particles, then potential energy. Okay, so that is the thing. Understand the thing guys. In internal energy, movement of particle is kinetic energy. In internal energy, interaction of particles is kinetic energy. Sorry, potential energy. So total internal energy is kinetic energy plus potential energy. Okay, so you have to write down the heading internal energy, write down from here to here and the formula. This is the notes. Okay, next thing is the absolute. Okay guys, here we have a miss. Sorry, don't ask this notes are notes send mari adu malalla. You will ask please send the notes. No, write it down. The absolute value, it is value got mixed sorry, missed. The absolute value of internal energy cannot be measured and only delta U means change in energy can be measured. Very important point guys. Absolute value of internal energy cannot be measured. We can only measure the change in internal energy. Why? Because internal energy will keep on changing based upon the movement of particles and based upon the interaction of particles. So that's why it will be not absolute value of internal energy, it will be change in internal energy, because internal energy keeps on changing based upon the, suppose work I am applying the work. So what is happening? It is compression, the volume is decreasing, right? The movement of particle will be more speed, because if I will compress, space will get less, so particles will start hitting more. Okay, sorry, if I will do the compression, the space will become less, the movement of particle will be slow. And then if I will do the expansion, so space will increase means now the movement of particle will be faster. So that's why we will not say the absolute value or exact value of internal energy. No, it's not possible. Absolute value or exact value of internal energy cannot be measured. Only we can measure is change in internal energy. So that's why change in internal energy is nothing but delta U. Next point is next point you have to write is internal energy of a system can change. So see, internal energy of a system can change. So that's why we have to find change in internal energy, not absolute. Internal energy of a system can change when heat passes into the system or out of the system. Obviously, internal energy, guys, either heat passes into the system or out of the system, and work is done on the system or by the system. So these are the things how the internal energy can be changed. So see, when heat passes into the system, understand very important thing, guys. This is related to the like problem also. We will solve this here. This questions. We will solve the NCERT questions also. Important hai bhai. Now understand one thing. Internal energy system, when internal energy of system can change when heat passes into the system. So when heat is passing into the system, what is happening? Temperature is increasing, right? When heat is passing into the system means system is absorbing the heat. The system is absorbing the heat means temperature is increasing. If temperature is increasing, what will happen? The movement of particles will be faster. So change in movement means what? Change in kinetic energy will happen. Okay. And the same, if heat is going out of the system, means it is the movement of particle will be slow down. So again, change in the kinetic energy. And then work is done on the system. Same, work is done on the system. So the space will get less. So movement and interaction will be less. Movement will be less and interaction will be high. Why? Because the work is done on the system. If work is done on the system, so compression means what will happen? The space will be less. If the space will be less means movement will be slow down, but interaction will increase, because the space will less means what will happen? Interaction will be increase. So if work is done by the system means the expansion will happen. If expansion will happen means what is happening? We will get the more space. More space means movement of particle will be high, and more space means what will happen? Interaction will be slow down. So this is how the internal energy will change. So that's why we will not say it's an exact internal energy or absolute internal energy. It will be change in internal energy. And how the change? Based upon the heat is going in the system or heat is going out of the system, or work is done upon the system or work is done by the system. Heat and work. So write down this point from here till here. Now next is, in case of ideal gas, PV equals nRT. Okay, pressure and volume is directly proportional to temperature. In case of ideal gas, internal energy of a system is a function of temperature. That's it. It's not a function of work or heat. It is a function of temperature. That's it. It is a function of temperature. Because see, ideal gas formula we know, PV equals nRT. Means what? It's directly proportional to the temperature. So it's a function of temperature. It is a function of temperature. Because N is what? N is the number of electron lose or gain. R is a universal gas constant. To these two does not care anything. Main thing is what? Temperature. So it's a function of temperature. Okay, write on this point from here to here. Then guys, after that we will see the IUPAC sign convention. Already I have said you. See, plus Q and WQ. First we'll focus on the plus. Plus Q and WQ. See, plus Q means heat is added to the system. Heat is added to the system means heat is acting upon the system. Heat is added to the system. Okay, means system absorb the heat, means system absorb the heat. You can see here, see this heat is added to the system means heat is acting upon the system, means system is absorbing the heat, system is absorbing the heat. So anything upon the system, anything upon the system, positive. So you can see here, heat is added to the system means heat is acting, means heat is going to the system, or system is absorbing the heat, so heat is going to the system. Okay, so it is positive. So that's called endothermic reaction or endothermic process. Next you see plus W means work is done on the system. The work is done on the system, it's compression. Okay, see here, work is done on the system, work is done on the system, the work is done on the system. On the system means positive. So no need of by hurting anything, just see that anything which is on the system or to the system means to the system, upon the system, then it is positive. Anything which is away from the system or by the system, it is negative. The plus Q means heat is added to the system, endothermic reaction, endothermic process. Plus W is work done on the system, compression. Negative Q means heat is removed from the system, means heat is going away from the system, removed from the system, means system to surrounding. So exothermic because it is exit, going. The sign convention is very important for the problem, guys, very important. And then minus W is what? Minus W is work done by the system. Work done is by the system, expansion. Okay, for example, when a gas is against external pressure, right? So gas is working against external pressure means this is a piston. The pressure is applying here, right? But work is done by the system. The system is working against the external pressure, or you can say against the atmospheric pressure, because external pressure is nothing but the atmosphere pressure is also acting upon that. Okay. So after that, what we have to write? After that, you have to write this IUPAC sign convention. And no need of drawing the diagram because already the diagram you had drawn before. Okay. Yes, sir. So this is the important thing you have to see. Now we will come for the first law of thermodynamics. Don't write anything, just understand. This is very easy thing, guys. Write on the heading first law of thermodynamics and write down this first point. See, the first law of thermodynamics is essentially a statement of law of conservation of energy. Understand one thing, guys. First law of thermodynamics is not the law of conservation of heat or not the law of conservation of work, nothing, or not the law of conservation of mass. No, it is a law of conservation of energy. Why? Because what is happening on the system? Heat or work, heat or work. So heat and work both is a energy. So first law of thermodynamics is a law of conservation of energy. Okay, that is the reason. So we know that. Okay, write on this first point from here to here. Okay, from here to here. Now write on the second point from here to here. What is the second point? It tells, this is a definition of law of conservation of energy. This is a definition of law of conservation of energy. So it tells, obviously, guys, we know the law of conservation of energy, law of conservation of mass, easy peasy, lemon squeezy. Cholo, focus karo, guys. It tells us that energy cannot be created or destroyed, only converted from one form to another form. It will get converted from one form to another form. That's it. So see, whenever you have to write the law of conservation of energy, okay, or law of conservation of mass, so just don't write this much like energy cannot be created nor be destroyed. This is a wrong answer. Some examiner will give the answer, but some examiner will give the marks, but this is a very wrong answer. Very wrong answer, guys. What you have to say? You have to say energy cannot be created nor be destroyed, only it can convert it from one form to another form. That is the last point you have to write. Only it can convert it from one form to another form. So write on this point. And now understand this concept, guys. This concept is very easy and very peasy and very lemon squeezy and very important, guys. Okay. If you understand this concept, from here we are going to write down the formula of delta U, formula of change in energy, formula of change in internal energy, sorry, change in internal energy. Otherwise, if you want, you can by heart the formula. What is the formula? Delta U equals Q minus W. But we will understand this concept, because based upon this concept they had asked the question over here, and based upon this concept even in the JEE, NEET, CET, everywhere they are asking a question. To understand this concept, very important. Chalo bhaiya, those whoever the person is in your mind, usko nikalo bhaiya. Chalo remove them and focus here. Chalo bring your brain guys, chuttu sa brain. Chalo bhai, jaldi chalo. Now see what will happen here. Now you have to see here. This is okay. Now see here what will happen here. This is the system. I will take this system. Now understand, very important topic. This is the system. Okay. Upon the system, I will apply the pressure with a piston. Okay. So this is the piston. Okay. This is what? This is the piston. This is the piston. Okay, piston. This is the piston. And now what is this? This is the, inside this you can say the gas molecules. Okay, this is what? This is the system. This is what? This is the system. This is what? This is the system. Okay, now understand the very important thing guys. Now we are not doing anything. So obviously we know naturally things what will happen. Here guys we have some atmospheric pressure. Obviously atmospheric pressure will be there. So that atmospheric pressure will be applying on the piston, right? You can say the external pressure, because the pressure is applying from outside, or you can say the what? Atmospheric pressure. Both are same. Okay. So here normally we will see in the normal condition we are not applying anything, nothing, just we have a system. Upon that system it's closed with a piston. Okay, now understand one thing. Initially what will happen guys, some external pressure or some atmospheric pressure will be there, atmosphere and all, it will be applying on the piston. And the same, you know, this the molecules of gas or molecules of water, it will also applying the pressure from downside to the piston, right? Because particles of gases, the particles of liquid keep on flowing. If they keep on flowing means they keep on hitting each other. If they keep on flowing means what will happen? They keep on flowing. So keep on flowing means what will happen here? They will keep on hitting each other. Or they will keep on hitting the wall of the container. Or they keep on hitting the piston. So what is happening in this condition? In this condition we can see that some internal pressure is also applied on the system, and some external pressure is also applied on the system. So this is the initial condition. Okay, this is the initial condition. So initial condition, what will happen? See here. Initially internal pressure equals to atmospheric pressure, or you can say external pressure. Chalega, jo bhi ho chalega. Understand? Right. Because here what will happen? So atmosphere mein some pressure will be that it is acting already on the piston, and we know inside the system we have a molecule. So molecules will keep on moving in a random motion. So they will be hitting each other. They will be hitting the wall of the system. They will be hitting the piston. So internal pressure will be also there, external pressure will be also there. So initially what we will talk? Initially we will talk that internal pressure equals to external pressure or atmospheric pressure. Now what we will do? Heat is added to the system. Now what we are doing? We are adding the heat to the system. Means we are adding heat to the system. Means system is absorbing the heat. So we know it is an endothermic process, and it will become plus Q plus. Okay. Now what will happen? Very normal thing. I have explained you before also. Again I am explaining you. If system will absorb the heat, now we are adding the heat on the system. Okay. So external thing we are adding here. If system will absorb the heat, what will happen? Inside the temperature will increase, right? Inside the system the temperature will increase. If inside the system temperature will increase, so what will happen? the molecules will start moving in a random motion, and the speed of the movement will increase. The speed of the movement will increase, and what will happen? Now the particle will start hitting the wall of the system, hitting each other, and then they are hitting the piston with a more force, with a high force, right? With a high force. Why? Because when heat you will transfer, so what will happen? The inside the system, the temperature will increase. If temperature will increase, the movement of particle will become more fast, means there is an increase in kinetic energy, because movement of particles means what? There is increase in kinetic energy. So see here, Q is added to the system, means it is an endothermic process, and positive here. Q is added to the system, which increases the kinetic energy. I explain now, which increases the kinetic energy of the particles, which in turn increases the internal energy of the system, right? Because what will happen? Temperature is increasing, movement of particle will increasing, kinetic energy is increasing, so everything is increasing. So this is inside the system, this is inside the system. So what is happening? Internal energy of system is also increasing. Internal energy of system is also increasing. So what is this? U1. Internal energy I will take as a U, right? Guys, I will not take delta U, because I am not talking about change in, I am just talking about the internal energy of the system. Internal energy of the system will also increase. The internal energy means U. Internal energy of the system will also increase. So this is the initial, so I will take as U1. Okay. They said increases the kinetic energy of the particles, which in turn increases the internal energy of the system. Understand? Don't write anything, guys, just understand first. Then they said this increases in kinetic energy. What the increases in kinetic energy will also increase the inside pressure. So what will happen? It will also increase the inside pressure. The inside pressure will also increase. The inside pressure will also increase. If inside pressure will also increase, so what will happen? The piston will go little up. 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 The piston will go little up and it stops. So again what will happen? Some external pressure is there. The piston went up, and now what will happen? The internal pressure becomes constant here, right? However, the internal pressure applied, then the piston become up, right? Piston went up. After reaching up, what will happen? Now the piston is constant. The internal energy got constant. Why? Because now I am not adding the heat. Once I have added the heat, inside the temperature increases, inside the movement of particle increases, inside the kinetic energy increases, inside the internal energy increases. With that, the piston level increases. After that, I am not applying the heat. I stop the heat. The internal energy is stopped. Now what will happen? External pressure is there also. So now internal energy again equals to some external pressure. Internal energy again equals to some external pressure, because every time we want what? We want the equilibrium condition. We want the equilibrium condition. Not we want, every time it will come the equilibrium condition. Here piston starts to move up. Piston starts to move up till internal pressure equals to atmospheric pressure. Means in the it will reach again to the equilibrium condition. Till that the piston will move. Once it will reach the equilibrium condition, means internal pressure equals to atmospheric pressure, again the piston will stop. So they will again reach to the equal condition, means equilibrium condition. Okay. So that's why what you have to do is write from here till here. Okay, write on from here to here, and then draw this diagram. Draw this diagram. So this is the after that. Okay. So now understand one thing. How the internal energy formula begins. Sorry, not internal energy. I will tell you how the formula is there. I will tell you. First now understand here. चलो भैया चलो जल्दी भैया important है जल्दी focus करो here. So now what is happening? See, internal energy we get to know U1. There is an increase in energy. There is increase in internal energy. Increase in internal energy means first I will take the initial U1. Now I have to find the U2. Now what I have to find? I have to find the U2. Understand guys? Cholo, 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 cholo. The focus. We have to find the U2. So U2 means what? See, U2 equals to U2. U2 means the final initial energy. Initial energy. Okay, final initial energy. Understand how we will write the U2 final initial energy. Very important guys. How we will write the U2 final initial energy. Understand the thing. What we will see here, we have a internal energy. Here we have a internal energy. Which internal energy? When the heat came, moving temperature increases, movement of particle increases, kinetic energy increases, which in turns internal energy also increases on the piston, and the piston lift up till the internal pressure equals to atmospheric pressure. Till that piston will lift and the piston will stop again, and again the equilibrium condition will held. Okay, so what is happening? Increase in kinetic energy will increase the internal energy. So here I will take that increase in internal energy as U1. So what is happening? Increase in internal energy. Okay, so we get to know increase internal energy. Now the two thing is happening. Q. What is happening? Q means heat. Heat is what? Heat is added to the system. Means heat absorbed by the system. So what is happening? Plus Q. I can write a small q, I can write capital Q. Both are same. Don't get tensed in this. So what is happening? Heat is applied to the system. Means system absorb the heat. So plus Q. When the system applied the heat, we know that from down what is happening? From down the work done. From down what happened guys? Work done on the piston. So piston went up. The work done on the piston, so piston went up. Means work done by the system. Work done by the system means what? Minus W. See here, work done by the system. देखो रे प्यारे, work is done by the system. अरे ओ रे प्यारे, it is minus W रे. So I will write down minus W. So what will happen? Like this we have to derive the formula. Like this the derivation will come. If you want, you can by heart it. But if you want to clear the like JEE, NEET, CET exam also, you have to know the basics. This is the NCERT basic, the conceptual, which you have to know. Then only you can able to solve the problem. Otherwise, just by heart it. So that's why work is done by the system. So what will happen? Minus W. So see here, U1 will go that side because like term same side. So U2, U1 is this is plus. So it will go minus. That side means minus. So U2 minus U1 equals Q minus W. Plus Q means this. Plus Q लिख लो भैया. Plus Q minus W. So U2 minus U1. Final minus initial. What is that? Delta U. Okay. Delta U equals. चलो इधर I will write. Delta U equals Q minus W. Delta U equals Q minus W. This is the formula how it came. Delta U means change in internal energy equals Q minus W, because Q heat is acting on the system. So that's why this all changes is happening. If heat is released by the system, movement of particle will be zero, kinetic energy will not be there, temperature will decrease, the movement will decrease, kinetic energy will decrease, internal energy will decrease, nothing will happen here. So that's why heat will added to the system, the Q minus W, because as kinetic energy will increase, internal energy will increase. So work done is done by the system to the piston, so piston will lift up, right? So this is the formula. Understand, delta U equals Q minus W. Sometimes guys they will give W, delta U, you have to find the Q, or sometimes they will give delta U, Q, you have to find the W. So but main equation is this, delta U equals Q minus W. I hope this equation is clear to you, right? Yes sir. Now see here. Okay. So after this, after writing this all the things, you have to draw this piston diagram, and then however I have drawn, you understand, draw that only, write down U1 and all everything, and then write down these expressions, first, second, third. This is a very important. Okay, after that guys, we will solve one important है भाई, important, we will solve this. See here, if heat q is added to the system, heat is added to the system, heat is added to the system means endothermic, right? System absorb the heat, so it will become plus q. Heat is added to the system and work is done on the system, work is done on the system, on the system means plus w, plus w by the surrounding, then change in internal energy, then change in internal energy. The change in internal energy is nothing but delta u equals q minus w. Okay, sorry, delta u equals, we have to take the value of q and w. So change in internal energy, it's based, how we will make the change in internal energy, it based upon the q and w sign. So no need of by hurting the change in internal energy, no need of by hurting the value of change in internal energy. What we will do, just we will see the how q and w sign changes. Okay, so here what will happen, q is plus, so it will become plus q and w is plus, so plus w, delta u equals plus q plus w. That is the answer. If suppose they will say heat is done by the system, heat is done by the system and work is done on the system, then change in internal energy is what? See, heat is done by the system means minus q and work is done on the system means plus w. If suppose they will say heat is done by the system is minus q and work is done by the system. Okay, sorry, heat is done, I am saying, sorry, heat is released from the system. Okay, heat is released from the system minus q and work is done on the system plus w. Or suppose they will say heat is released from the system minus q and work is done by the system minus w. So how, see how the value is changing for the internal energy, how the value is changing for change in internal energy based upon the condition for q and w. So q and w condition is very important for writing the change in internal energy value. So you have to understand the concept, then only you can write. If you will by heart, to bhaiya khatam, tata, bye bye. Okay, moi will happen. So you have to write down this, this is a question and this is the answer for this. Okay, okay. Now we will see here. Chalo. Okay, oh shit, kahan chala gaya? जब कर लिया वैसे लेटेस्ट okay. And guys, see, if you want more, like, you know, want more knowledge to be here, you will get from here. If you want, you can read the line by line for the NCERT textbook also. It will give the more advantage. Okay, otherwise everything we had did here completing everything here. So see, everything, if we'll talk about delta means change, delta T means, see, change in temperature, it is final minus initial. Change in internal energy, final minus initial. Okay, chalo ek minute, I have to see one thing. Take it guys, then. Okay, then they had given here general case here. General case, delta u equals q plus w. So it depends, okay, how the things are changing and all. Okay, so now here what they say, this is the important thing. For a given state, change in state delta q, and see here, this is very important. They had given a general case is, we had kept, see, in general case we kept both positive. General case we kept both positive means heat is added to the system, work is done on the system. Delta u equals q plus w. But after that what they said, for a given change in state, q and w can vary depend on how the change is carried out. So as I have said, you q and w will keep on varying. It's like this, plus minus, how it will change depend upon how the change is carried out. Okay, so now see at this point, if there is no transfer of energy as heat or work in isolated system we know nothing will transfer. So work is also zero, heat is also zero, then internal energy is also zero. So these are the condition you have to understand. Okay, isolated system, nothing is transferring means if it is isolated system, so q is zero, w is zero, delta u is zero. Okay, so if you will read, see, I am teaching you all the things here, but if you will read the NCERT, you will get the like more and more clarification in the deep. So read the whatever the topics I'm completing here, read the NCERT for that. Okay, so now delta U equals, what is the general condition? General condition in which we'll keep the Q and W, the heat and work, both as positive. So delta U equals to plus Q plus W. So this is the first law of thermodynamics. General case means where we'll keep the Q as plus and W as plus. So delta U is what? Plus Q plus W. So this is the first law of thermodynamics. Okay, see, the energy of an isolated system is constant. Constant means zero. Why it is constant? Because system is isolated. Nothing can go outside, nothing can come inside. So it will be constant. Okay, now we will see this thing. This is like, see, the volume expansion. Volume is increasing, volume is decreasing. If we'll increase the pressure, right here what you understanding, we are pushing the piston. We are pushing the piston means if pressure will increase, what will happen? Volume will decrease. Here guys, what is happening? We are decreasing the pressure. We are decreasing the pressure. If pressure will decrease, what is happening? Volume will increase. If pressure will increase guys, volume will decrease, and pressure is increasing, what is happening? Kinetic energy will increase. Here if pressure is decreasing, volume is increasing, so kinetic energy is also decreasing, because movement depends upon the pressure. So these all are the terms, very important thing. Now see here, now understand, express the change in internal energy. We have to express the change in internal energy based upon this condition. The first one is express the change in internal energy. Express the change in internal energy, delta U equals, now see here, no heat is absorbed by the system. No heat. No heat means in place of heat it will become zero. But no heat is absorbed by the system from the surrounding. No heat means zero. But work is done on the system. Work is done on the system. On the system means it is plus W. So delta U equals, it will become W. Delta U equals W. Now they asked what type of wall does the system have. Guys, we have studied two walls, adiabatic wall and diathermic wall. So here you can see no heat. No heat. No heat. Who will not? Yes. Who will not allow the heat to transfer? Who will not allow the heat to transfer? Adiabatic wall will not allow the heat to transfer. So if heat is zero means in first condition it is adiabatic wall. In first condition it is adiabatic wall. Now second condition, delta U equals, no work is done on the system. No work is done. So work is zero on the system, but Q amount of heat is taken out from the system. So heat is releasing the system. Heat is going away from the system. If heat is going away from the system is minus. So it will be minus Q. So delta U equals minus Q. Delta U equals minus Q. Now what type of wall does the system have? Okay, so heat work is, guys, work is zero, but heat is transferring. Heat is transferring. The heat is transferring means what is happening? It is diathermic wall, because diathermic wall allow the heats to transfer. If heat is not transferring, adiabatic wall. Heat is transferring, diathermic wall. Okay, or you can see here it's like a what you can say, or you can say, like, you know, thermally conducted, because heat is transferred to thermal conducting. You can say that also. Better it's like adiabatic wall. Okay, sorry, diathermic wall. Heat is zero, adiabatic, because adiabatic will not allow the heat to transfer. Now third number. W amount of work, okay, delta U equals W amount of work is done by the system. Work is done by the system. By the system means minus W. On this work is done on the system, then plus. By the system means minus. And Q amount of heat is supplied to the system. The heat is supplied to the system, inside the system. System is absorbing the heat. So it is delta U equals plus Q minus W. So that's it. From here, from this condition, we have to see that either Q is going in or Q is going out, or work is done to the system or work is done by the system. According to that, we can able to write delta U expression, any type of expression they will give, we can write the delta U expression. So this is the very important thing to understand. Okay, so here what type of system would it be? Okay, so see what is happening. Work, so amount of work is done by the system means piston is going up, because work is done by the system. By the system, piston is going up, and amount of heat is supplied to the system. Heat is supplied to the system. Heat is not getting out of the system. Heat is not transferring, right? Heat is not transferring from system to surrounding. So what is happening? It is a closed valve. It is a closed valve. It is a closed valve. Okay, so see here, closed valve. It is a closed valve. It is not adiabatic. See, understand the difference between closed and adiabatic. Closed means it is closed. Heat can come, heat can go. Closed means heat can come, heat can go. Adiabatic means what? Adiabatic means transfer of heat will be zero. If heat transfer is zero, heat transfer is zero, directly we will say adiabatic valve. Okay, so here heat transfer is also there and work is done. Heat transfer is there and work is done. So work is done the piston, right? They didn't set the matter and all. So it is a closed system. It is a closed system. That's it. Okay. So this is for the today's class. In the next class, we are going to continue the next thing. So thank you. Bye bye and take care.